Hello and welcome to the third video in a series. We previously had explained how hash works and the effects of it. Also, we explained how information is chained. So putting together those two earlier concepts with the spreadsheet right now, we can explain how mining works. The example here is very close to how Bitcoin works, so let us assume that it is a Bitcoin network, because we're going to use a proof of work to establish how it is done. So here we have the first line number 3, that I'm highlighting right now, where you have 5 different users. Okay, you have Alice, Bob, Charles, Daniel, and Eva. You might notice that their names aren't exactly written in with the right characters, but they are using a kind of a code. Why is that? Because in Bitcoin, when you have a wallet, you don't have it as a name, but you have it as a very long string, and that is the information that you need to to operate there. However, you might be the owner of it, but it doesn't have your name. So that's why you can keep yourself anonymous in the network. However, the activity of a certain wallet is publicly seen by everybody. So what I'm doing here in line 1 is establishing the initial coin offering. So I'll make Alice and Bob have each one 10 and 5 coins, and the other ones will have 0 coins, just for the sake of this example. Usually this doesn't happen. All the participants on the ICO will have some coins. The total of coins that we have is 15, okay? And what you can see here from what we've learned previously is this. Once I get the list and the balances and I calculate the hash for it, the number should be the same as long as the names of the coin holders and the balances are the same. So you can see that here and all these fields for all users is exactly the same. So this established that everybody agrees on the initial balances for everyone. Okay, so how does mining work? First, Alice wants to transfer to Daniel 2 coins. So how does that happen exactly? So first, the software will have to calculate. Okay, so Alice had 10, so now she will have 8. And Daniel, that had 0, will now have 2. Okay? One thing that you can see here is that we are repeating the balances for everyone, but we are also putting here on this line the information that Alice is sending to Daniel too. The same information is identical throughout all the users of the blockchain. But the last line, we're changing it here, and then I can explain why. You see that for Alice, if Alice is able to calculate the block correctly, it will get a reward, and we're establishing it here as a 0.1 coin for her. If Bob is the one calculating it correctly, it will be his reward. And subsequently, you have all the other users with these attributions. So what you can see here is this content where I have Alice plus 01 and Bob 01 is different. So this means that even though all the rest is equal, a slight difference will make the hash here be different to the hash here. Okay? So basically what the users have to do is to add an information on this block to calculate it in such a way that will generate a valid hash. What is a valid hash? Remember on the previous videos that I said I want to reach a goal like the last 2 digits of the hash will be AA? That's exactly this. To make it easier, I did this. I put this information here where you can see the 0. If I change it to 1, you'll see that all the hashes will automatically change. You see here? And I'm going to change it to 2. You can pay attention to any hash of this line number 4, and you'll see the hashes changing. Okay? And here I just did something very simple. If any of the hashes ends with AA, that's the rule here, then this will become true. Okay? So not to change number by number here, let's start with the 0. And let's use the resource on Excel for this kind of calculation. So he will give me 100 random numbers. So I want that this value, sorry, is number 1. This means it is true. And I'm going to change this value here, the nonce, the number that you add on top of the block to do a valid calculation of the hash. So what happens here is this. 4, 7, 10, 12 calculations, 15, 18, and it goes on trying to calculate a valid number. Wow, what happened here? We got a hit. This means that Charles was the one calculating the block correctly. He was able, with the new balances, with a list of transaction, and with the attribution of the credit, to calculate a valid hash. And this is why it became green. I did a resource here of conditional formatting that whenever I get a right number, it gets green. So this means that Charles won the competition, but this is not enough. He must broadcast this information to all other users on the network, and then they will calculate if this hash is correct. Once it is, they will accept it and put it on their ledgers as well. So this means that if I get this information and I copy it to another ledger, let's say Daniel's, I'll just put here just the contents of it. It means that once I have the same information here and here, I'll have the same hash. Okay? So then everybody should have the same information. I'll just undo this for the sake of the explanation, and I'll go on generating a new block so you can better understand, and I'm going to repeat the process I just did. Okay? So I have some lines here that I have to unhide. Here they are. So let's say that the second transaction, Bob wants to transfer to Eva 1 coin. Okay? So this means that Bob had 5. So now he will have 4. And Eva, that previously had 0, will have 1. Notice that also Charles had 0. But once he won the competition and the other participants accepted that he won, he's entitled to a credit of 0.1 coin. So we will have it here. So the same race again starts over. So what we have here is this. So I have that this field becomes true. So goal seek, I want that this cell becomes 1, becomes true. And I'm going to change this cell here. So it will keep on changing, and then you can see that as it changes, the hashes are constantly changing. And whenever I get a hit on line 5, you see some green lights blinking on 6, but that's not what I'm looking for. I'll have a valid block. Let's see, I already have 70 interactions, 76. Here we are. We got Daniel with a hash here, calculated correctly. And then what Daniel will have to do at this moment is to inform the other participants that he has a valid block, and then they will have to accept it. Once they accept it, you have the confirmation of the block, because at least 51% of the network, but let's say that all the network agrees to it, and then the block is accepted and the ledger will continue being consistent. Okay? So here it is. The fun thing, however, is to notice this. Here's the total of coins that you have. I had 15 here. Notice that the amount of money raised because a hash was calculated correctly. There were a lot of resources, basic computers and electricity to do that, and the amount of money starts growing for every coin that's mined. There's a lot of sophistication and mechanisms on the algorithm to guarantee that this is done in such a way that is fair and it is valid. But there are some very important issues as well that you must observe, like mining concentration and things like that. So what you have here is a last transaction here that pretty much is the same. And then what you have to do, I'll just repeat that again as the last time we're going to see this mechanism. So I want that this cell becomes true. If I change the contents of this one, you see the repetitions, you see the hashes changing. So this is mining, and it means that if you have, we have 5 here, and now L is 1. Good. So L is now is the chosen block for the network. This means that if you have 100 people, you will waste the processing of 99 of the guys, and one of them will be chosen as the one entitled to receive the reward. So the security of the information is on the algorithm that does the calculation, that will prevent you from getting a double spending, but also it will sync all the network every 10 minutes in the case of Bitcoin. For other networks that might be different, and then you'll understand how mining works. But it's a lot of processing just to calculate the hash, because for instance for the balance calculation you did it previously to start calculating the hash itself. And right now you can see some information that I'll make available, but the quantity of energy spent for this calculation is really representative, and it's growing. Right now, at the time of this video, 0.5% of all world's electricity is being consumed for hash calculation on Bitcoin. And like in the next 5-10 years, it will be something like 5% if it stays on this trend. Okay, well, I hope you enjoyed the video, and I'll make available as well a link for you to download the spreadsheet and use it. But be aware that you must install the SHA function provided by Phil Fresley, and have fun. Feel free to comment or to get in touch with me. Thank you for watching. Bye.